Who are you? What's your name?
Hey, my name is Thomas. I'm Supermicro, Technology Enablement. Today we're showing Habana, we're showing Intel Arctic Sound, the new, better known as Intel GPU data center.
Oh yeah,
they launched today. And
they just launched it today.
First and only ones to show them here at the show.
Oh, very nice. Great. Very nice.
We also have the Habana, and we even have the Habana chip to show you today. So
oh my goodness.
Without the cooling fan, you can actually see what it is. Very shiny.
Great. So what's Intel saying about Habana, or what do they want to do with Habana?
So today Intel launched the Gaudi 2, which is the next generation of Habana Gaudi chip. So it's a dedicated AI chip, extremely fast. It's going to be very competitive to the next generation NVIDIA's as well. Very price competitive, but mainly in raw performance, it's really going to kick some ass here.
So they showed a graph or a chart in the keynote. Did you see that in terms of the performance comparison?
No, I did not see that.
One. Okay.
No.
All right. I'll get that for you.
I had to get ready for the booth.
Yes, I recorded it. Do you want to show a little bit about the Gaudi machine, what it entails and stuff?
Yeah, so this is the Gaudi. This is the back end, not that sexy. This is all the fans we have here, but the real business end of it is the event. The interesting thing about the Gaudi is that we have the 6 external 400 gig connectors. That means 2.4 terabit in scale out bandwidth to other Gaudi boxes. So you can make a really very fast cluster. And the scale out and the scale out performance is completely linear when you add more and more systems. Contrary to other competing systems where you have to go through network adapters, these Gaudi chips, they have networking built into them, and that means it is unprecedented in the performance you get when scaling out. So this is what Habana is all about. This is particularly for computer vision and for NLP workloads. It's a dedicated AI chip for
and
AI
is this
training.
what San Diego Supercomputer has deployed? With the
Yes, so San Diego Supercomputer has about 42 of these bad boys installed. That means a total of 336 Gaudi chips, and all interconnected at 400 gigs. So it is one of the fastest AI supercomputers they have at San Diego Supercomputer. So doing a lot of very interesting workloads on AI, on wildfire management in California, on particle accelerator data, and various astronomy events they are doing AI on. So very, very interesting research being done.
Nice. And so they've announced a Gaudi 2, and then we have a press release on it and everything. And so what is Gaudi 2? How's that different than
Gaudi 2 more than doubles the performance internally between the chips. That means the bandwidth between chips is more than double. Also, the raw performance in the chip is about 3x faster from the second generation. And they've changed from a 16 nanometer technology to a 7 nanometer technology. So a lot of inherent performance is built into that change in chip architecture.
That's great.
So, there you have it. Habana Gaudi, the Gaudi 1 system we have here, Gaudi 2. We're probably going to be able to launch POCs in August, September timeframe, and full production at the end of the year.
Okay, great. And if anybody wants more information, go to our website, or can they call you?
They can call me anytime they want.
Okay, it's Thomas Jorgensen.
Call me and I'll be there.
Okay. Okay, like the song, right? You're Blondie.
Exactly.
Okay, great. Thanks a lot.
That address, the broad capabilities that customers require. But with Gaudi processors, we're able to actually address the highest end deep learning training use cases. And we see demand growing for these types of applications to deploy implementations of object detection or image classification or natural language processing. Like the Bosch example we saw earlier today, we have to train increasingly large data sets and complex models. And this can be very time and cost intensive. But with Gaudi, we're able to train those models much more efficiently and effectively. And in fact, Gaudi is deployed today in AWS's EC2 cloud, providing customers up to 40% better price performance than competitive GPUs. With Gaudi, simply put, you can train more and spend less. And I'm delighted today to announce the availability of our second generation Gaudi, Gaudi 2, our 7 nanometer Gaudi 2 deep learning training processor. And Gaudi 2 is launching today, providing customers with a major leap in deep learning performance. And to talk more about that, I'd like to invite Eitan Medina on stage to show us a demonstration of Gaudi.
Hi Sandra, I'm so excited to show you the performance of Gaudi 2. We are connected to a Gaudi 2 server back in our data center, and I can show you a live training run from my monitor. So let's kick off the training run. We just started training the ResNet 50 computer vision model on a single Gaudi 2, the one that Sandra just announced. End customers wish to train more and pay less, so they care about 2 things: the cost of using the server and the time it takes to train their models. Model training depends on the amount of data needed to achieve the target model accuracy. And the key factor here is the speed or the throughput that the accelerator can process the data. The higher the throughput, the faster we can train, and the faster the customer gets a model they can use. The logs being printed on this screen show the live progress of the model accuracy and the throughput in every iteration of data. To help visualize the progress, we have on the left a live TensorBoard screen. And you can see that Gaudi 2 has already reached the steady-state training throughput of almost 5,500 images per second. So, let's compare Gaudi 2 to the A100 GPU. While Gaudi 2 is implemented in the same 7-nanometer process as the A100, it delivers twice the throughput for both ResNet 50 and BERT, the 2 most popular vision and language models. Now, we have already deployed 1,000 Gaudi 2s in our R&D data centers, and Gaudi 2 is available for our customers. To learn more, check out my session at 4:30 today and come see the demos in the show floor. Thank you.
And thank you, Eitan. And we can see that we can use Gaudi 2 to accelerate time to train, which benefits all our customers.
Sandra, this was great. Thank you for coming out here to my living room and spending some time with me. I think we've so far showcased some really incredible innovation, and it really shows the advancements and how Intel will help businesses and entire industries to unlock future opportunities. But I think we need to pause and need to get the bigger picture and question ourselves, is this all?
This monitor is connected to a Gaudi 2 server back in our data center. And what we did now, we just started compiling the ResNet 50 computer vision model for training on a single Gaudi 2. Now, as I mentioned before, end users care about training more and paying less. And a big factor in it is the ability of the accelerator to process as much data, because in order to reach your target model accuracy, you actually are training on a lot of data. So for training more and paying less, what you want is an accelerator that can process as much data as possible. So the logs you see being printed on this screen are used to track the actual progress of the model accuracy and the throughput in every iteration of the data. And on the left side, you have an active TensorBoard screen that will help you visualize the progress. And what you see is that the Gaudi 2 has already reached the steady-state throughput of almost 5,500 images per second in training throughput. Next, what I'd like to show you is how does it compare to the A100 GPU. So let's switch back.
So let's take a look at ResNet 50 actual performance across several solutions. And what you see here listed is V100, our first generation Gaudi in terms of throughput, and then A100 40 gig and A100 80 gig. And what you notice here is while Gaudi 2 is implemented in the same 7nm process as the A100, it delivers approximately twice the throughput on ResNet 50 training. And what we did here is we did the testing exactly as an end user would do. An end user will get access to a high-end DGX machine or an instance in the cloud, and a real end user would pick up the TensorFlow container from NGC. And what we did here is that we use, and you see the parameters below, we use the recommended parameters for best throughput on the GPU and compared it to Gaudi. Gaudi is available to our end customers both on the AWS EC2 cloud with the DL1 instance that we launched in Q4 of last year, and on-prem through our good friends at Supermicro who are supporting customers with the X12 servers. Both types of solutions have 8 Gaudis inside the server with a dual socket Xeon. Habana software stack also integrates natively with Converge.io, which is a super efficient MLOps solution that Converge supports end customer with. And the unique attribute of this solution is the ability for customers to increase the utilization of their on-prem servers and burst very efficiently into the cloud. This is an independent capability that Intel has, and Gaudi naturally fits into this solution. Now let's talk about what attracted customers to Gaudi. Our first generation is in 60nm, and if you notice, let me go back really quick. If you look at the ResNet 50 number, you notice that the throughput on Gaudi is in between V100 and A100. However, because that solution is so efficient, we are still able to offer a very fundamental price performance advantage when you compare the cost of using the servers and you combine it with the actual throughput. So if you look at the cost savings to end customers on the Amazon EC2 cloud, and the way to do that is that you look at the price of using the instance. For example, the P4D instance hourly cost is $32.77, while the Gaudi-based DL1 instance costs $13.11. Right? So when you combine that gap in pricing to the end customers that comes from the efficiency of the solution, and you combine it with the actual throughput, you actually get 46% better price performance when using DL1 on ResNet 50 compared to the P4D. And you can see in the language model is a similar picture. So you can say, overall, you can certainly expect up to 40% better price performance versus P4D, and around 60% versus the V100 based instances. So this is what attracted customers to us when evaluating Gaudi. Supermicro, what you see here on the right is the Supermicro X12 Gaudi server. These days, Supermicro is busy working on bringing to market the Gaudi 2 based server later on this year. But the first implementation of a supercomputer using Gaudi was by San Diego Supercomputing Center that implemented the cluster taking advantage of the native integration of Rocky on each Gaudi chip. And what's unique about this cluster is that what you see here are 336 Gaudis implemented in 42 servers, where the 24 100 gig ports that come out of each Gaudi are directly connected to a centralized Ethernet switch. As simple as that, a single hop switch that allows taking in much more bandwidth from every node and potentially accelerating multi-node training. And this supercomputing center is now available for the research community to apply and get access to